we need to solve, and we need to apply some properties for determinant. Okay, now what you can see, these are triangles matrices or diagonal matrix. Okay, this one is the diagonal matrix. This one is also diagonal matrix. So what we're going to do, we're going to find a way to solve this matrix, and then since we have like a triangle form, and you can see that we have this the diagonal form. So that means what we're going to get as answer, it will be for the determinant, it will be straight 2 4 times 2 times 5. This is what we're going to get to take, and in order to find the determinant, so to save some times. And then the same goes for this one. You can see we have this diagonal. So the answer to this matrix would be 7 times 5 negative 1, which will give us negative 35. And let's just continue. And this one, you can see we got ourselves another triangle block here, and then because of that we're going to multiply this diagonal line. So it will be 1 times 3 times 2 times 5, which will give us 30. So this is what you should know about calculating a determinant of the diagonal matrix. Next, you are asked to find the determinant. So you should know these rules. The determinant of A equal to the determinant of A transpose. You're still gonna get the same answer. Now here are some other properties that you should know. So it's the same as the determinant of A times determinant of B. Let's see. Now just pay attention to this other form. The determinant of A plus B is not equal to the determinant of A plus the determinant of B. Okay, the same goes for A minus B. It's not equal to the determinant of A minus determinant of B. Okay, and then let's see this formula. A matrix times B transpose matrix equal to determinant of A, and just determinant of B transpose. So, and we know that we could just rewrite this, so it will be determinant of A, determinant of B. Okay, let's continue. For example, and we are asked to find the determinant. Okay, times constant. This will give us Kn, determinant of A. Okay, and let me give you another example. Let's say you are asked to solve So the answer to this, it will be K is what you see inside, and N is the size of the matrix, which will be 3. That's the size of the matrix. Determinant of A. And the same goes for this other example. Determinant of 5b 2 times 2 is the same as 5. Okay, and the power of the matrix is actually 2 times 2, so that's why you see going to have a 2 there. Then determinant of b. Okay, let's say for example you're asked to solve this one. Okay, as you can see, because this is the power of the matrix, that will be going to have a power of 2. Okay, times those determinants, and then we can separate them this way. Okay, let's say for example we need to solve this matrix, to find the determinant of this equation. Okay, this is one example. Since we have 3 by 3 matrix, that's why we're going to have 3 there, and then we separate them like this, and then the transpose, determinant of a transpose, it's the same as the determinant that we had before. Okay, let's say for example we got this example right here, and the answer to this, we can convert it into this one, and everything to the power of n. So we could just take out the n, and let's say for example we were tasked to solve. Let me just give you a simple definition of a to the power of n. It's actually a, let's say for example we had a to the power of 3. It's the same as a times a times a in terms of matrix. Okay, let's say we need to solve this determinant of 3 times ab squared. So what we get to be to the power of 2, as you can see, the value of n, determinant of a b square. Just to make it shorter, I'm not gonna repeat this. Okay, now we can rewrite it in this form. So this is the same as having 9 determinant of a times determinant of b square. Okay, and then we can adjust it further on to be 9 determinant of a, okay, determinant of b, everything square. Okay, let's say for example we have this matrix. Okay, so let's say m times n. So we actually multiplying these two matrices, and then the size of this one will be n times m, and the answer to this matrix should give us ab. Okay, and then it will be, the answer will be m times m, what you see here, m times m. So if we have something like this and we need to find the determinant of the matrix of the same size, so the determinant of this matrix that you see here, a times b, because we have the same size, the answer to this will give us 0, because we have the same size there. Or maybe I should give you an example now, which you can see where you can actually apply it. So let's see one example. This is the example. 4 times 3 multiply, okay, by b times 4. Okay, and the determinant, the multiplication of these two will give us b, and we get 4 by 4, 4 times 4, the size of the matrix. And then if we have to find the determinant of this matrix, okay, for example, we need to find the determinant of this matrix. The answer to this matrix will be 0, because 4 times 4, because of that. So this is what you should know. And let's see what we can do more. So this is what we just did. Okay, kind of a bit confusing. Now let's say, for example, it was this case b times a, okay, and the answer to this, we get something b a, and we get something n and n, so it should be n and n. And then if you have to find the determinant of this matrix, for example, so determinant of this matrix, it's not it's actually b and a, n times n. The answer to this will not going to be equal to 0, so we get an answer that is not 0 for this case. And let me give you one example. So let's say, for example, we actually trying to get the determinant of a b, which is of power 3 times 3, that's like the dimension of the matrix. So the answer to this matrix will be 0. No, let me just correct it. ba will not be equal to 0. So this is what you need to know. And then okay, let me give you some extra example. Let's say we need to find the determinant of this matrix, similar to what we just saw. Okay, and the answer to this matrix will be 0, because we already have a triangle here. Okay, now we're going to solve what is on the diagonal. So it will be 3 times 4 times 0, which will give you 0. Let's go with another example. Let me call it maybe C, D, E. This is E. 5, -3. And the answer to this will give you 0, because as you can see, we do have this 0 here. Then we're going to solve it in diagonal, so it will be 0 times -3, and then 0 times 5, so it will give you 0. Okay, let's say, for example, we have this matrix. The determinant of this matrix will be equal to 0. The reason why it's equal to 0, you could see, if I may say, this is row 1, row 2, row 3. You could see row 3 equal to negative twice row 1. So for that reason that you see, the determinant of this matrix will be 0. Now, this matrix will be equal to 0 if you take the determinant of this matrix equal to 0. If you take this one, it's actually C1, C2, column 3, column 4. You could see that column 4 equal to twice column 1. So if 2 times 2, 4. 1 times 2, 2. Negative times 2, -2. 3 times 2, 6. That's why we make it, the determinant will be equal to 0. And since we already know that the determinant of A times B matrices equal to determinant of A times the determinant of B. Okay, we already know this formula. And then determinant of A transpose will be equal to the determinant of A. We know these two formulas, and there's one more. Determinant of A minus 1 or inverse will be equal to 1 determinant of A. And the determinant of a scalar matrix will be equal to the power of n determinant of A. Okay, let's say for example this is our matrix. We have a zero matrix. Okay, and then you are asked what is to find the determinant of this matrix. The determinant of this matrix will be equal to 0. That's what you should short all zero matrices. The determinant will give you 0.